Hi guys, we're going to be doing some final review with some Zoom videos. I'm going to try about 3 questions with you today and post a short video and see how that goes. I have some sample questions. This is material from our first unit. We were working with lines and linear functions. So I'm going to try 3 questions with you. The first one is finding x and y intercepts of a line and then graphing that line. Okay. So remember, an x-intercept had to do with where the line crosses the x-axis. That happened when y was 0. So I asked you to plug in a 0 for y, which would make the y term go away. And really, you're solving 4x equals 16, which you get x equals 4. Likewise, a y-intercept was when x equals 0. So we plug an x of 0 in here. I created 2y equals 16. Solving that would get y equals 8. Those are x and y intercepts. We're going to plot them now. And x of 4 is over 1, 2, 3, 4. So it's crossing right there. A y of 8 is up 1, 2, 3, 4, 6, 7, 8. Let's say it's right about there. The line is passing through these 2 points. So I'm going to connect them and make that type of a line. Okay, our next question. Could you write an equation of a line given some points? So we called the points x1, y1, x2, and y2. And the equation of the line we're after is y equals mx plus b. So the m had a formula. You'll need to know this for your final: y2 minus y1 over x2 minus x1. And then we also had another equation we used after we calculated the slope. We used a point slope formula: y minus y1 equals m x minus x1. So we'll use that formula as well. Let's try this one first. We are going to subtract our y's. So that's looking like a 5, take away a 2. On the bottom, we are taking away our x's. It's a 9, take away a negative 3. Well, what's 9 take away negative 3? It's 9 plus 3. So it looks like we have 3 on the top, and we have, what's this going to be? 12 on the bottom. So we're getting the slope of a 3 over 12. We'll call that a fourth. Throw this information into this formula now. Y minus y1, which I guess we'll call 2, equals slope x minus x1, which we'll call negative 3. Looks like we're going to have a fraction here. Normally, I would distribute at this point. We'd have y minus 2 equals 1/4 x, and then what's a fourth of 3? We call that 3/4 or 0.75. We're going to add the 2 over. I'm kind of writing on top of my graph here, sadly. Let me pull this information down here. Add the 2 over, and it's y equals 1/4 x. 2 plus 0.75 we'll call 2.75. It's about 3. To graph this, of course, on your final, this would probably be a whole number. It'd be a little easier for you. 2.75 is going to be up 2 and 0.75 more, which we'll call right about there. The slope is 1/4. What did that mean to do? This was our rise over run. We would go up 1 unit, which would take me to about there. I'm going to go over 4 units. 1, 2, 3, 4. Take me to about there. So I apologize for writing on top of this, but the line looks maybe, let's say something like that. The equation was 1/4 x plus 2.75. One more to try, which will be my third question. Can we graph a simple exponential equation or function? I usually had you start with the positive numbers. So could you find 2 to the 0, 2 to the 1, 2 to the 2? And then we tried the ones with the negatives after that. 2 to the 0, you remember, was a 1. 2 to the 1 was 2. And 2 squared is 2 times 2 is 4. The negatives we sometimes did on our calculator if we weren't sure. 2 with a negative 1 on a calculator, you're going to get 0.5. By hand, this would mean 1 over 2 to the 1. And that's a half. A half, of course, is 0.5. Negative 2 power here, 2 with the negative 2 would be 1 over 2 squared. On a calculator, it would get you 0.25. 0.25 is about a fourth there. I'm going to try to plot these quickly. I'm going to go to the left 2, up a fourth. I'm going to go to the left 1, so back 1, up a half. Here's 0, 1, so stay in the middle and then go up 1. To the right 1, up 2. To the right 2, up 4. These dots are giving us the pattern, this exponential pattern. Connect them so that it does look exponential. You might want to connect them like this. Okay, that's where we're going to stop this little video, and then I'll have another one for you soon. Thank you.